Good morning, everybody. Thanks for joining us on this wonderful, wonderful Thursday morning here in the West Coast. I am Josh Long, the developer advocate for the open source Spring technologies here at Pivotal. And I am joined by Skype, that was a little worrisome. I am joined by my pal, Peter Leto from Vaadin. Say hi, Peter.
Yeah, hello, everybody. It's Peter calling from Finland.
Yes. Late in the evening there, early in the morning here.
Yeah, exactly.
We meet in the middle on open source. Those are our Twitter coordinates, email coordinates, GitHub. If you have questions, comments, feedback, anything we can help with, we are happy to do so. Don't hesitate to reach out, carry the discussion forward online. This code lives on that GitHub repository that's on the bottom of the slide there. So if you're keen on trying it out or following along at home, please don't hesitate. It's should be pretty easy to get going if you have Maven installed in Java 8. So Maven can install and go. And this, of course, is a picture of Peter and I a few months ago as we built a really, really wicked, awesome user interface with a joystick, an actual joystick that you could use to manipulate a flying drone. And of course, that whole project was Vaadin and Spring Boot based. So the feedback, all the HTML5 integration with the joystick, all that stuff, all going through a Vaadin front end, talking to a backend written in Boot, which ultimately talks to the drone using a TCP client that we wrote. So that's us. And we are here, of course, to talk about Vaadin and how to build apps with Vaadin and Spring Boot. So let's first take a look at why Vaadin. Peter, what do you think?
Yeah, well, I don't know how many Vaadin developers we have here or how many people in general are from the current participants using Vaadin, but Vaadin is a server-driven Java framework for building modern internet applications with a component kind paradigm for creating web applications. And as you can see from the picture, there's a fancy picture of a reindeer, and also the logo of the Vaadin sort of resembles the horns of the reindeer. And why reindeer is because Vaadin is actually a Finnish word that means reindeer, although it's not very commonly used, but still an old word that sort of also brings us back on thinking maybe some Scandinavian influence on the actual framework. But yeah, that's more like philosophical point of view. Anyway, why Vaadin and why to use Vaadin? Vaadin actually is built on two key concepts. Another one is developer productivity, and another one is user experience and the whole idea of building user interfaces that are based on easy-to-use components with clear APIs and clear mechanisms on how to compose different kind of views of your application by using pre-created set of components that you can also extend if you want. So the programming model is quite close to, for example, Java Swing that enables you to just bundle components together, implement some kind of listeners for them, and with the listeners to change and mutate the actual state of the application. So all of this is provided by the Vaadin framework in such a way that developers don't have to concern themselves with HTML, with JavaScript, or any other, let's say, lower abstraction level concepts like the communication, request response cycle, WebSockets, these kind of things, since Vaadin handles all of this for you and lets the developers to concentrate on the part that is really important for them. So this is just building the actual high-tech look and feel application front end for your real business backend that today we will demonstrate together with Spring Boot. So let's, for example, have a little sneak peek into our code. We can, for example, say that we have two components, text field and button, and we have some layout into which we add the components. And for our button, we add a simple click listener that performs some action when the button is clicked. And in this case, you just see a simple Java 8 Lambda that says that Vaadin UI should display a notification where it says hi and gets the value that is currently residing in the text field. So this information is on the server side, and the value of the text field is available on the server side when the request is sent, so that the actual implementation for the click listener can react on the changed content in the client browser. And how this really works is that initially when user navigates into a URL where Vaadin application is deployed, he gets an initial HTML page that contains, for example, the theme, including all the graphical assets that make up the look and feel of the application. And it contains also the JavaScript client-side widget set, which is sort of a thin client for all the Vaadin widgets, meaning that when developers write their application, what they're really doing is that they're using the server-side representation of the components, let's say the part that has the higher abstraction level. And on the client side, the widget set and the thin client is just rendering the server-side state to the client browser. And initially, when the Vaadin application is loaded, when the thin client is started, initially the size is approximately 1.2 megabytes, but with different kind of compression techniques that, for example, Spring allows us to do, as well as different reduction techniques on the widget set, we can drop that client-side initial JavaScript content to as low as almost 140 Ks. So after the initial thin client has been loaded, a init method is called from the Vaadin UI class that will simply initialize the UI with the initial components. And in our example, we, for example, had the text field and the greet button. So the information about the UI content is sent to the client side, where it is then rendered by Google Web Toolkit-based widgets into the actual web browser. And of course, as we're using pure HTML and JavaScript to do this, you can, with CSS, very easily customize and theme the look and feel of your Vaadin application to any of your liking. And well, when there is some user interaction with the browser, we, for example, type something into the name field and press greet button, a request is sent to server side. And this request contains the information what has changed on the client side, meaning that there's now a value in the name text field and a specific button was clicked. And this information is bundled up into one request that is sent to server, and it's quite minimal, 261 bytes of data. On the server side, we have the click listener implementation, and at this point, Vaadin framework has already routed back the actual communication to the proper UI instance in the proper HTTP session of the web user, meaning that the proper click listener instance is invoked by the framework, where the actual data that was already given from the client side is now set as value into the text field's server-side value. And hence, we can use this information to produce our notification that now says, "Hi, Jonas," as that was the value that was typed into the text box. So this is now the response to our initial HTTP request that then informs and tells the client-side engine, the thin client, that, okay, now you should just render our notification for us. And this is sort of the whole communication abstraction that there is in Vaadin. So without really having to write any part of HTML, JavaScript, CSS, only thing you did is that you just had the server-side components, text field, button, and you were able to create a UI that already automatically asynchronously communicates with the client and server. So this gives us two key values that the framework provides. Another one of those is the developer productivity. So with very little code, you can actually create very impressive UIs. And then on the other hand, the framework allows you to create UIs that have rich user experience, UX. And this is brought to you by the wide variety of different kinds of components right out from the core distribution of Vaadin. But also, on the other hand, Vaadin is also very extendable. That simply means that from vaadin.com/directory service, for example, you can download almost 500 add-on components to your framework that you can, right out of the box, just use with your Vaadin application. And today we'll be demonstrating to you some of the core components of Vaadin, some of the core features of Vaadin, and also some add-on components, like, for example, a widget that enables us to point locations on a map, for example. So on high level, this is what Vaadin is about. All right, back to you, Josh.
Build a rich user interface applications. Am I muted? Let me make sure about that. No, that should be okay. Can you hear me?
Yep, you're there.
Okay, good. Okay, good. Clearly, Vaadin is a very productive way to build the rich user interfaces and applications. You know, they enjoy the benefits of both being server-side business logic with rich dynamic client-side HTML5 widgets and components. And then, of course, for the back end, I think, as you'll see in this talk today, that Spring Boot makes a very, very compelling choice. Spring Boot is, of course, what we are hoping people will use as the sort of entry point when they start their applications with the Spring platform. It's very easy to get started with Spring Boot. We'll go ahead and look at that right now. Start, same thing as usual, start.spring.io. Go to the form, fill out the basics. You say, okay, I want to use, let's see, Bootful, Vaadin, places. Okay, I'm going to build an application. Bootful places. Okay. It'll be Bootful. Okay. Or just call it places, who cares? We want a Maven project. Want to choose a build type, be it jar or war. We'll go ahead and choose jar for embedded awesomeness. Choose the version of the Java language you want to use. 1.8 is, I really think that should be the only choice. I mean, you can use Java 6, but that's end of life, so don't. You can use Java 7, but again, if you're on Java 7 and you can afford it, go to Java 8, Choices of Groovy or Java. Of course, this is just Spring. It's just a JVM type system, so please don't hesitate to use your favorite language, but these are the ones we have particular awareness and support for out of the box. Choose the latest and greatest cut of Spring Boot that you want. 1.18 is the GA stable release. 1.20 M2 is the latest and greatest bleeding edge cut of the next big release. And then you choose the style of workload that you'd like to support. So for our case, we're going to use MongoDB. We'll go ahead and choose Facebook. We want the actuator to get visibility into metrics and so on. We want the web support. And I think that's enough for now, right? But again, these are not necessarily technology specific. They're more about, I need all the dependencies required to get started with MongoDB or JPA or JDBC or whatever. I need all the dependencies I need to get started with the web, with web programming, etc. Hit generate, and you'll be given a zip file here, places.zip. Okay, unzip that. I'm going to open this up in our IDE. This is, for all intents and purposes, just a very basic sort of boring, a very boring sort of standard stock Maven and Spring directory structure. So you open up the Maven pom.xml, and I'll go ahead and open that on the side here. And what you get is a Maven pom.xml, which we're going to, you can see that each checkbox corresponded to one of these opinionated starter dependencies. These transitively import everything you need to get started with this thing, data, using Spring Data MongoDB and all associated technologies, including the MongoDB driver and Spring Data and all that stuff, and all that. Everything you need to get started with Facebook, etc. All the stuff you need for getting started with unit testing. So this is kind of what we can, get out of that starter page. But we're going to go ahead and paste in a more sophisticated version of it so that we can kind of move a little bit faster here. So we're going to go ahead and just copy and paste dependencies here from off screen. And it's going to be a superset of these same dependencies, but they're all going to be there. We'll look at those now. And then we're going to paste in a few properties. Again, just a superset of the properties that we've got here already. So, like so. We've already got some properties specifying the source encoding and the build encoding, output encoding, etc. We're going to go specify, well, we don't need this one. We're going to specify Vaadin version, Vaadin plugin version, and GeoTools version. And then we're going to go ahead and use a few build plugins to handle the actual processing of some of the stuff that Vaadin does behind the scenes. Again, you're only going to see this or work with it, I think, at most once per project, but you know, per developer, per station. Okay, there you go. Add enable auto imports. And again, all this code is available online if you care to follow along. So if we look at our dependencies, you can see we've got the same things we looked at just a minute ago: the Facebook, MongoDB, web, actuator, test, etc. Then we have the Spring Boot Vaadin integration, and this is the project that's the highlight of what we're going to look at today. And then we have some supporting dependencies here that we've installed mainly so that we can exclude a few pieces. Otherwise, you can just rely on the Spring Boot Vaadin integration to get you what you need. Vaadin themes, we're going to go ahead and bring that in. Hibernate validator, which you can use optionally if you like. There's a third-party library called the Vaadin extensions, and it provides a lot of handy-dandy convenient components that are, again, this is one of the benefits of Vaadin, is that it has such a rich community of developers, and the components that they develop and share are awesome, right? And you can pull these things sort of off the shelf and reuse them as you like. In this case, we're doing so with this component set. The Vaadin charts library, we're not using it in our app, but there's no reason you couldn't. Easy uploads provides a really, really nice way to do file uploads, drag and drop HTML5 file uploads. The V leaflet bits provide nice support for mapping, like Google Maps or OpenGIS maps. When we look at our code here, the code is pretty simple. It's just standard Spring application. This is a Spring Boot application, and it's going to be started. Spring Boot is going to see the application.class. It's going to see the arguments that you passed in. It's going to use that. It's going to find this class here, application, and it's going to see at configuration, which is a standard Spring 3 ism, Spring 3 or better, which tells it this is a Java configuration class, which in turn means that it can contribute bean definitions by defining methods that have at bean on top of it. It can contribute at components. It can find all components in this package or beneath this package. It'll find any components that are annotated with Spring stereotype annotations, like at component, at controller, at repository, or even meta stereotype annotations that themselves are annotated with at component, like, for example, the Vaadin component annotation that we'll encounter very quickly here. And then, of course, the Spring Boot at enable auto configuration, which tells Spring Boot to apply as much common sense defaults as possible, please. And it'll do that by providing, out-of-the-box configuration for all manner of different things. And in this case, because we have the Spring Boot Vaadin integration on the class path, that module will contribute auto configuration that will set up a lot of stuff for us. A lot of the moving parts required to get Vaadin working just disappear. And it is in this way that using Vaadin with Spring Boot can be, very, very, very productive. You don't have to worry about setting up a lot of stuff that you would otherwise have to normally worry about. So our first things first, we're going to go ahead and build an application that talks to Facebook and gets place information, like shops, cafes, things like this. We're going to get that place information and then store it in MongoDB, and then we're going to create, using Vaadin, very, very efficient, very clean user interface, so you can manipulate that data. Spring is very good at working with data, and Vaadin is very good at displaying it and making it easy to navigate and manipulate. So we'll go ahead and tie those two together today. The first piece is, of course, a domain object, something we can actually use to model the state that we want to store. So we're going to create a Mongo place, or a place object using Spring Data Mongo, and it will be mapped to documents in MongoDB of type place, right? So any place structure. And remember, behind the scenes in MongoDB, all this is eventually just stored as JSON. So what you have here is an object whose properties are going to be stored as JSON fields, and then we have annotation here saying that this is a particularly special field. It's going to be indexed for geolocation and GIS queries. So it'll be a longitude and latitude that MongoDB knows how to talk to and knows how to do, queries around that, right? So you can ask questions like, find me every record that's within so many X of this point on the map. And again, we're using longitude and latitude here to index and query against objects in real space on the Earth. But you could also just do basic geometry. I mean, this is a very nice feature either way. We have another Spring Data annotation here at ID, which tells the Spring Data Mongo mapping mechanism and other mechanisms like it, like Spring Data Cassandra, for example, and Neo4j, that this annotation is to be used as the key or the primary key or the ID or whatever that means in the backend store. But otherwise, this is just a regular POJO. So it's serializable, although it doesn't need to be. And it has readers and writers in this case because we want to be able to manipulate the state of the POJO in our UI. Where we have a copy constructor here. The copy constructor is going to read data from Spring Social's Facebook API, and then we'll just copy the fields from that Facebook entity into our class. So here we're going to dereference all the basic information about the place, and then we're going to dereference the location information from the Spring Social page.getLocation object. And here's that special care being handled for the GIS query, right? The position, the index. To manipulate places, we're going to use a place repository. This is a basic Spring Data-ism. It's this idea that you can define standard CRUD style operations like find, create, read, update, and delete, as well as basic data manipulation operations like sorting and paging, data query operations. All of that stuff is defined in these interfaces. These interfaces themselves are they're just that. They're interfaces, but they can contain convenient methods like find all and find all given a sorting condition, find all given a paging condition, etc. Spring Data will see those methods, and it'll see these custom finder methods that we've defined, and they'll implement them for us. So I can say place find by city string C, and this will actually get converted behind the scenes into a query that will look at all the documents and find the one that has a city whose value is equal to C. The query below will be used by the GIS engine inside of MongoDB to find all records that are within a certain distance D of point P. So again, this will take advantage of the index that we created earlier. We don't have to implement this interface. Keep that in mind. We're going to inject references to type place repository, but we don't care who's implementing it because we know Spring Data will do it for us. So this is a very convenient way to get stuff up and running very quickly. And then with that, we need to actually seed our database, right? So to do that, we're going to talk to Facebook. We're going to use Spring Social Facebook. Spring Social Facebook provides a very handy Facebook object, which is basically the super type of our Facebook template, which works as you might expect. It works very much like the JVC template or any of the other templates that you're probably familiar with in Spring. And that, in turn, of course, is going to use it's going to use the two configuration properties, Facebook.appID and Facebook.appSecret, which by default, Spring Boot will attempt to find in either application.properties or application.yaml. I'm going to rename it to application.yaml, paste in the information that we need here. And then we're going to go ahead and delete these two different directories. We don't need the static or the template directories for now, but Spring Boot was nice enough to provide them out of the box. We also want a REST template. The REST template provides easy access to other REST endpoints, which we can use to actually drive our data feed here. We'll paste in a command line runner object like this. And the command line runner is an interface. It's a basic Spring Boot type. It's an interface that has one job. It says, when Spring Boot starts up, call this method back called run and pass in as the arguments the string array that's made available in public static void main string arguments. So I'm going to say, I want to define a bean that implements that interface. Spring is going to see that bean, and it's going to see that it implements that interface. And much like it would if you were implementing initializing bean, it'll call the appropriate lifecycle method. It'll call run and pass in the string arguments that it got from Spring application.run up here, right? Or rather down here. So these arguments are what you're going to have here. We're using a Java 8 Lambda. Remember, the Java 8 Lambda syntax is, for any type X with one method, like command line runner, for example, I can return an anonymous inner object like this. But if you think about it, all I really want to do is pass a method body around. That's all I'm trying to do, after all, is tell Spring to run this method when the code gets set up. So I can just do that. I can pass a method body around like that, or like that, right? Once Spring Boot starts up, it's going to run this command line runner. Inside of it, we ascertain our own IP, and then from one web service called icanhasip.com, then we call another web service and say, give me the geolocation information for my IP, and this is the parameter. So we're saying REST template get project, and give me back a map, which has as its keys the JSON structure fields, and has as a parameter the IP that we have obtained from the first call. And then we'll dereference the longitude and latitude fields from the JSON structure, and then delete everything in our MongoDB database, and then use the longitude and latitude fields to talk to the Facebook API here and query for all places in this array list. So we're saying for every place name, Starbucks, Phil's Coffee, Ike's Place, which is a great sandwich shop, Bite, another great sandwich shop, Umami, which is another great burger shop. For all these different places, go to Facebook, for each queue in this list, go to Facebook, call the Facebook.place operations, do a search, passing in Q, the longitude and latitude that we're at right now, and then a perimeter. And then for each result, take the page that we get back from Facebook and save it using a place repository. So we're actually just using this as a chance to bootstrap our database full of places. And then we iterate through everything we've just saved into the database by printing it out. Finally, we're going to actually use the place repository and just sort of zoom in, if you will. We're going to get the subset of records in our MongoDB database that match this GIS query, right? If you could imagine this on a big sci-fi screen, you could imagine, somebody going enhance, and then the picture just enhancing and the points becoming clearer as we zoom in on the location on the map. So with all that in place, I think we can now kick off the run here. We should see everything we need. Whoops, go back. Okay, there it goes. So what you see, perhaps overwhelmingly, there we are, is that the application started up and gave us the IP of the current machine. It gave us the longitude and latitude and all the other GIS information relevant to where I am. Right now I'm in San Francisco, right about here, metro code, area code, etc. It's going to give me all the records near my current IP, basically. So it's going to find all these Starbuckses in this area, and they're quite a big distance. I remind you, San Francisco is 7 by 7 miles, so it's, even the other side of the city is really close in all fairness. So we have a lot of records here. Good. And then finally we get to the end of the records and we say, okay, let's zoom in and just find things within 1 mile. And then that's a much smaller subset, as you can see. So that's the same data, just refined by using a GIS query in Mongo. Now we have our data set. We can afford to just comment this out for the balance of the app because we already have data. Let's go ahead and build a UI to actually manipulate and work with this data. Now, Vaadin, of course, is a natural fit for this. We're going to look at this Spring Boot Vaadin integration here. And I think the first thing we need to do is build a UI. I'll do that while Peter explains. Peter?
Yeah, sorry. Okay, you were starting to create a UI, and this is, of course, done in such a way that the UI that you create, you simply extend from a UI that is defined in the Vaadin server package. And what we actually see here, if we stop for a moment, we're actually looking into the server-side UI implementation in such a way that there is just one init method that gets the Vaadin request as a parameter. And this is the initial place that is invoked after the thin client has been loaded to the client browser and the actual client-side engine JavaScript part has started. So when the initial request comes in from the browser after the thin client has been started, then we invoke the init method. And what we're effectively doing here is that we're creating a tab sheet component that is just one component out of the core components of Vaadin, and we're saying that it should take the full size. And in this case, it means that the full size is now the size of the current browser window. So the tab sheet is simply taking the whole space that is available. And into the tab sheet, we will later on add two different kind of views as the actual sheets of the, as the tabs of the sheet, of course. And eventually we're setting the whole tab sheet as the content of our current UI. And if we really quickly consider the annotations at the top, maybe the one that is most interesting up there is the Vaadin UI. So it's the mechanism how Vaadin UIs are brought together with the Spring integration. So one really important aspect in this annotation is that it's also having an annotation called UI scope. And why this is important is that if you consider average Spring application, it involves quite a bit of injection, auto-wiring, all these kind of things. And it's really important that you inject things which are relevant for the particular UI instance to the correct UI instance. And why is this? Is because every time you open a new browser tab, or every time you, for example, refresh your browser tab, a new UI instance is created. So you get new places UI every time you do one of the mentioned operations. And when you consider that you would inject, for example, a view into your UI that is by default a singleton, it means that the same view would be shared between all the UI instances, which would, of course, eventually create problems. So that's why one of the biggest benefits of the Vaadin Spring integration add-on is that the UI scope is defined as a Spring context for you and provided for you so that you can really use it just as a scope. Alrighty. Still talking about those two remaining annotations at the top, I mentioned that the thin client is something that is preloaded when the user for the first time enters the web page. So this is defined by the widget set annotation at the top, and also the theme annotation is the composition of the graphical assets and CSS that makes up the look and feel of your application. So with Vaadin 7.3, there is new theme engine called Follow, and it is a SaaS parameterizable, meaning that it is SaaS is sort of a syntactically awesome style sheet. So it's, how would you say, like a more advanced version of CSS that gets automatically compiled to CSS. So the Follow theme is something that with just a couple of parameters allows you to completely tune and change the look and feel of your entire application. So it's more like a parameterizable theme engine. So anyway, these three annotations are the mainly interesting ones in every Vaadin UI. And Josh here pasted in a couple of other views. So we, for example, have the places table view, which is a table kind of view that displays our data that we have loaded from the Facebook with our location information. And this table view is marked with Vaadin component so that it's available as a Spring Bean. And the reason why it's using Vaadin component annotation instead of just the component annotation is just to avoid confusion between Vaadin UI component interface and the Spring's component annotation. But it's still just the real component annotation from Spring.
It's documentational, very much like at repository in Spring Framework proper. There's very little. There's no reason that we couldn't introduce a lot of different functionality, but as often as not, these annotations are documentational. Underneath the hood, it's all the same type of component.
Yeah, exactly. And for the mentioned reasons, of course, the view is also UI scoped. So it means that for every UI instance, you will get a fresh instance of the table view as well. And well, the table view itself is extended from the vertical layout, which is just another way of laying out components. And it's also Spring initializing bean, meaning that after the injections and auto-wirings have been done, the after property set method is invoked. So what we then do inside of our table view is that we first, for example, just if you just a little bit scroll up. Thank you. So initially what we do is that we auto-wire our place repository, meaning the repository into which we stored our information about these mentioned restaurants. And we, for example, also auto-wire something called place form. So this is just another component in Vaadin that we've extended to display editor for one single place. So we auto-wire that into the view, as well as an event bus that is a feature coming from the Vaadin Spring integration that, for example, allows to fire events inside Vaadin scopes in such a way that you can fire events that are broadcasted to all the views inside a UI, or you can fire event to the application scope that is potentially distributed with multiple different UIs in the entire Spring application. So these are just the basic dependencies of our view. Another thing we're doing is that we're introducing a list that is a table, and it is sort of property-aware table of the type place, meaning that the place is expected to have the mentioned properties, name, street, city, state, chip, and category. And we define that we also want to display the column headers with the same names. That's not mandatory, but just a way to tell you that you can define the column headers, for example, for the internationalization. And then we're just saying that the table should take the whole horizontal space available. So the content might grow up until, let's say, some limit on vertical direction, but after that, the table will produce huge scroll bars. But on horizontal level, the table should take all the space available from the actual view component. Then we have a couple of buttons. So, for example, edit and delete buttons. And well, they are just sort of simple buttons as you saw in the initial example. So there's a click event bound to the click listener when we, for example, click the edit button. And what we do is that from the place repository, we find one place that is currently selected from our list table, and we set that entity as the content of our editor form, meaning that we simply edit the selected entity that is currently selected from the table. And finally, we open our editor form in a new model pop-up window and say that the height of this window should be 90% of the current browser window height. Delete button is then extension of a button called confirm button, and it simply allows us to make a dialog, and when user replies yes to this dialog, we then do some operation. If he replies no, then we just simply close the dialog. And what happens here is that when you click delete button, we just call place repository and delete the currently selected place that was selected from the table again. After that, we just list the entities there, meaning that we refresh the table content and we, for example, fire place modified event into the event bus, meaning that if we, for example, have our map view that doesn't have any relation to our editor or our table view, the map still gets notified about some change in some place so that it can either be removed from the map or the location can be updated or something like that. Alrighty. Then we have another quite interesting part here. So as I already said, the class implements the initializing bean, meaning that there is the after property set method, and while or when that is invoked, we're already sure at that point we have auto-wired the event bus successfully. So we just say that event bus should subscribe to this particular object, meaning that in this class, we have a method that has event bus listener method annotation. And every time when there is a place modified event fired into the event bus, this method will then be automatically invoked. And well, in this case, we just refresh the content of the table and close all the currently open windows from the Vaadin app.
Okay, I'm going to go ahead and restore our form here. Let's see, we need a place form. This is a modal dialog that will let us manipulate the data for the actual form itself, for the actual place itself. I'll paste that in the bottom here. This is our dummy, it's a fairly uninteresting place modified event. This is what we're using to pass around notifications on the event bus. Okay. So places table view. Places table view. So that should be everything. This is our table view. We're injecting it into our places UI. We're going to use that. We're going to reference that component and add it as part of the tab sheet's sort of layout and geometry, and then set the content on the current UI to be that tab sheet. The table view, the places table view. Peter just did an amazing job explaining, so you don't have to reiterate over that. Place modified event, no big deal. The place form itself works very much like what you'd expect. It's just another component that is UI scope and Vaadin component. Peter, do you want to explain that while I compile?
Yeah, sure. So the place form is just an extension of the abstract form for the type place, meaning simply that this is intended to be a form that edits an object of type place. And all the properties that there are in the actual place object are to be shown as different kinds of fields inside the form. So we have a couple of text fields for the name and category, city, whatever, and also a field that is multi-file upload component, meaning that you can have a quite nice looking HTML5 drag and drop based upload that allows you to associate some files with this particular place, for example. And well, in this editor, you very simply instantiate these fields, auto-wire your properties, for example, the grid.fs template to just handle the uploaded images with the MongoDB. And finally, also the place repository just to, for example, modify the content of the particular place when you decide to store it. And well, there's also form layout, which is another layout in Vaadin. It is pretty much like vertical layout, but with the difference that the layout handles the component or field captions in such a way that they appear on the left side of the actual field component. And yeah, then we have the set entity method, which is just a mechanism on passing the place that we want to edit into our form. So there is a bean field group for the type place, and this is a Vaadin utility that is not a visual component, but just sort of a data binder which binds the data into the mentioned text fields. So for every property in our place entity, We just grab automatically the properties with Vaadin field group and bind them to the mentioned Vaadin field components for editing. Alrighty. Well then, a few other things. The place form constructor will of course simply just set up everything there is inside our form. For example, associates the save handler for it and tells what to do when save is clicked. So just to call the save method from the place repository, and again fire event bus method for the place modified event. And well, then also the display images if available. So this is just a mechanism. If there is already some image bound to the place, we just grab it from the gridfs template, create a Vaadin image widget for it, and set the source in such a way that we're able to read the image content from the MongoDB and show it inside a web browser image element, eventually through the image widget.
Okay. So
yeah, and then actually, well, at the end, now that you scroll to it, there's still a protected method that creates the content. So this is something that the abstract form intends you to override, that you sort of define the application or the form layout with that. So we just say that we want to use this mentioned form layout with our caption handling, add all the fields into it, and just wrap everything inside a vertical layout, meaning that we add our own form layout into it, and then we get the toolbar from the abstract form, which is just the default toolbar that might, for example, contain the save and cancel buttons and things like this. So the abstract form, for example, is now an add-on from the Maddon extension that we introduced in the beginning with the POM XML. And it is just a helper for you that enables creating, for example, this kind of form structures more easily for Vaadin.
Now, I added one thing while you were talking. I added this app widget set.quit.xml.
Yeah, that's very important.
Can you speak to that while I run this thing here?
Sure. So I've already a couple of times mentioned the word thin client. And what this really means is that Vaadin is built on top of two key technologies. On the client side, it uses the Google Web Toolkit for rendering the widgets, rendering the components that are the server-side representations. And on the server side, everything is based on servlet technology. And what the app widget.quit.xml file is the descriptor for the Quit compiler that compiles the client-side representations of components into the thin client that is loaded initially for the web browser. So this is just a descriptor for widget set. It is important that you have it in the case if you want to recompile your widget set, and the only time when you really need to do that is if you, let's say, add some additional component into your project that didn't exist with the core distribution. But normally, after the widget set is compiled, you will never have to recompile it, since the widget set doesn't contain your application. It doesn't contain your UI or the places form or the places repository or anything like that. Only thing that it contains is the client-side representations of the components. And this is sort of really important thing to understand regarding, for example, application security. So with Vaadin and Spring, you're never exposing your business logic or your data model into the client side, but instead only the drawing and rendering instructions of the widgets are part of the JavaScript thin client.
Awesome. I took the liberty of running the app and starting it up here.
Yeah,
this is our first tabular screen. It's nice. I'm a fan. Reactive, very, very. This is all that GWT dynamicism on the client here.
Yeah. So what we can really see here is our table that now contains the list of places. And when, for example, you click on those table column headers, it is able to sort the data inside the table. And how this really works is that the container that is on the server side backing this table is able to sort by any property that is of type comparable. So in our case, most of the things were just strings, so you can automatically alphabetically sort these columns. And when you, for example, click on an entry, the edit button is enabled for you. And as you click the edit button, we're just showing our form in this modal dialog way that then brings up the abstract form in a window showing our fields. And down there, you, for example, have now this fancy HTML5 upload component that makes it possible to just drag and drop files into this drop files box there that then displays the content of the file in image widget. And well, all the basic functionality of the window is there, so you can make it bigger, smaller, close it, open it. And this, of course, is not a native browser window. So this is just another piece of HTML DOM structure that is brought on top of your current UI when you open the window.
Yeah. Although if you're asking me, if you were to full screen this web page and then hide the Chrome, it would be hard. I'd be hard pressed to know this wasn't something native. This is a beautiful UI for very little work. Yeah. So I think we're making progress, but I think we can do better. How about you? Don't you think something befitting of all these different geographical spaces needs something better?
It's missing the wow effect.
Yeah, mapping, some sort of map representation. So let's go ahead and add a map view. Okay, go down here. I'm going to copy and paste another component here. We'll quickly get this out of the way. So, as before, we have another component here. Fairly basic stuff.
Yeah. Another component that is now extended from LMAP that comes with the Vaadin add-on that we introduced in the POM XML. So this is something that doesn't belong by default to Vaadin core components, but you can, for example, download this from the Vaadin directory. And as you download it, this map widget, it has a client-side implementation that displays actual scrollable map for you. And this is the reason why you, for example, have to compile the widgets at once while you bring in this new support or new component to your application. And well, in this case, it's all the same story again. We have an initializing bean that has the afterPropertySet method invoked after all the auto wirings have been done. We have the event bus, place form, and place repository injected for the same reasons as we did with the tabular view. And well, simply, maybe the biggest part of logic is here in the refresh places method that is invoked when place modified event is again fired into the event bus. And what we do there is that we just remove all the bits and pieces that are currently in the map, iterate over all the items in our place repository, and just for every item position a marker to our map, into which we then additionally add a click listener. So when you click the map node, you actually open up the place form so that you just get the place information from the place repository for the clicked item. So exactly the same behavior as with the table, but this time you can just click the items on the map.
Cool. So I'll go ahead and restore that. And just that places map view. And run it. Again, for the sake of the demo, we've been doing hard-coded strings inside the UI. Of course, you should take advantage of Spring's internationalization capabilities, even Vaadin has it as well. But if you're using Spring, you'll be happy to know you can still use it. Just inject a message source and resolve properties that way. Now, the application is up and running again. Here's the old one. Hit refresh. Now we have a new view here, map view, with all of our map points. We can zoom in as before. High fidelity, very, very beautiful. Full screen. Very, very fast, too. Let's see. So here's a Starbucks. I might exit full screen again. Go to the photos. Open up this Starbucks. Drag and drool. And then there we go. Same as before, right? You can edit the information, modify it, etc. If I click on a random point, I get the you clicked on notification that Peter alluded to earlier. And we can go back to the tabular view if we like as well. So again, a lot of functionality for very, very little work.
Yeah. So the tab sheet up there is now providing you these two different tabs, and what we just did is auto-wire two different view components in there and said that, okay, tab sheet, you should use these as your tabs with dimension captions, and that's it.
Right on. Awesome. So as we wind up our session here, I wanted to remind you that this is, of course, a Spring Boot application, which is fundamentally just Spring. So if you want to run this, you can. You have numerous choices. Obviously, by default, what you have here when you use Spring Boot is an embedded jar. So if you go here to the command line, do maven clean install, get test equals true, maven clean install, and then rebuild. What you'll get is an embedded jar that you can actually just run by doing java-jar. It's a so-called fat jar. There's a plugin in the pom.xml that provides this fat jar that itself contains all the other jars inside of it. This is invaluable for operations where processes rule, and this is also a natural fit for any kind of cloud environment like a Heroku or a Google App Engine or a OpenShift or a Cloud Foundry. So if I go to target here, I can do java-jar places.jar, and the application will spin up. And again, I can also change other things about this web server. Like, for example, the application is running right now. There we are. Go back here. Refresh again. Same thing as before. No problem. Details and all that. But because it's an embedded application, I now have the ability to add, niceties within my code. I can configure everything as I would like. For example, here, I can register an embedded servlet container customizer, which is a callback interface inside of Boot that works for embedded Jetty or embedded Tomcat. Here we're using the embedded Tomcat flavors. What this will do is serve up gzip compressed JavaScript and JSON. So, for example, all that stuff coming out of the Vaadin widget set compiled, bits here on the project all gets served up much more expediently this way, just by registering this. In the same way, you can also set up SSL termination. If you don't want to use embedded Jetty or Tomcat and you want to deploy to a legacy environment like a WebLogic, be our guest, right? Again, you can turn this into a Servlet 3 application very, very simply. There's actually documentation, the Spring Boot documentation about how to take an existing boot app and make it a Servlet 3 compatible WAR file. If you do, whether you turn it into a WAR or whether you leave it embedded, you can deploy it to the cloud with ease. This is already running, for example, in CFA, my Cloud Foundry account. I uploaded the app, and there's the code for this online has a Cloud Foundry manifest, which describes everything that Cloud Foundry needs to be able to run this, including which services are needed to be bound. For example, MongoDB, since we're using that for the images and the GIS information. So here's the cloud-bound version of the application. Same as before. Again, do whatever you want to do. Right? Drag and drool. Oops. Oh, the focus. Haha. Okay. Etc. Right? So same as before. Same kind of stuff. Right? Very, very powerful. Now, again, one question you might have is, well, what about session state on the cloud? Well, can I use that, in a cloud environment where typically it's sort of verboten? And of course you can, right? Cloud Foundry, for example, will give you session affinity. So if you have Vaadin application, which has a little bit of session state. Requests will be routed back to the same node. Heroku is a little bit less forgiving. It won't do session replication or session stickiness. But we have a project called Spring Session, which I encourage you to Google. You'll find the GitHub repository. It's not yet GA, so I didn't bother linking this demo to it. But it's out there. It's certainly usable. And what it does is it plugs into any server container and overrides the HTTP session object that's provided by the container, and then forwards all the reads and writes to a backend session store if you're choosing. By default, we have an implementation for Redis. And the benefit of that, of course, is that you can write to Redis or read from Redis from any number of nodes on a platform as a service. And you get session replication for free because Redis knows how to do session replication. It is a strategy interface. You can plug in your own implementation, of course. So if you don't want to use Redis and you want to use Couchbase or you want to use Memcached or whatever, Gemfire, whatever, it's fine, right? That'll work just great. And the benefit of this, of course, is that now you can have stateful applications like Vaadin. Not a lot of state, but you still have some state, of course, and that makes sense. So that works great, right? Now you have a really productive story. You have the ability to say, okay, I have data. I want to work with that data quickly. You saw how easy it was to take Spring Boot and Spring Data and Spring Social and pull together a database full of stores and merchants and so on. And then how easy it was to throw together a really rich, really, really beautiful graphics, intense Vaadin user interface to manipulate and work with that data. And then, of course, with something like Cloud Foundry, which is an open source platform as a service from Pivotal, the same people that make Spring, or something like Heroku or OpenShift or Google App Engine or whatever, it's very easy to get up and running. And Spring is, Spring and Spring Boot are cloud native. So this is a very, very, I hope you're as convinced as I am. This is a very, very productive way to go. Peter, I think we're winding up here. I would invite our audience to check out vaadin.com/demo, and then check out the actual Vaadin for Spring integration library on GitHub.
Yeah, actually, a few words about the integration library. Yeah. So the reason why it is still in the GitHub is that it is still currently a little bit work under progress, and we could say that it's today in beta. Hopefully, it will be released very soon as the official Vaadin Spring integration. So currently, it's still not official by the book, but definitely the most advanced integration and add-on for Vaadin to enable the Spring support, enable support for Spring Boot, all the cool stuff. So this is definitely something that Vaadin also as a company is currently heavily investing in and intending to release this add-on as the official Spring and Spring Boot integration for Vaadin.
Yeah. For those who don't know, that was the original seed code for that project was something that came out of a webinar that another gentleman, Petter, not my friend Peter here, but another great guy named Petter. Another great guy named Petter. He and I did a webinar talking about Spring and Vaadin back in December for Vaadin, and the sort of genesis of that code it came out of that collaboration. But of course, guys like Peter and Matti and others and Petter himself, of course, have taken it a lot further since then. So it's really coming along nicely. That was almost a year ago, so we're making progress. And then hopefully, I think we'd all like to see a guide on spring.io/guide. So again, if you have feedback, if you have things you want to see addressed, please check out the code, check out the bits, check out the guides and the demos and so on. And now, by the way, the code, of course, is on GitHub, so don't hesitate to check that out. And our email and Twitter handles are there. If you want to take the conversation further online, we're happy to have it. Happy to have questions, comments, whatever. And now I think we'll turn it over to Q&A.
Yeah.
Do we have questions, my friend?
Matti has already done a pretty nice job there, answering most of the questions at least. By looking at the questions, I think that one thing that people might be concerned is that what it really takes to scale Vaadin application, and isn't server-side way of building applications quite memory consuming. This is something that people usually tend to think when they consider Vaadin. And of course, this is the case. When you have the server, you also have the HTTP sessions that contain your Vaadin application, your Vaadin session, your UI, your views there. But then again, the average Vaadin session, of course, the size depends on how many views you have, what kind of things you do. But there are also very well-known best practices on how to build Vaadin applications. And for example, in this demo that we just did, we loaded a lot of places from the Facebook, for example, and put them into a table that displays them. This is, of course, doable as the amount of these locations isn't very high. But let's say that you loaded, for example, 10 million records from somewhere. It wouldn't really make any sense for every Vaadin user to make a container per UI that would load those 10 million records. So that would, of course, be waste of memory. So just by realizing that this is a matter that you'll have to consider in your implementation, and just by knowing that you're working on the server side and not really on the memory of the client browser, with these sort of guidelines, you are able to make Vaadin applications that are actually highly scalable. And another thing that also might be the case or reason for somebody to consider Vaadin is that whether it's pretty chatty or, for example, all the HTTP requests that go back and forth from the client to browser and back. Yes, that's true that there is communication between the client and the browser, but as you, for example, explained, Spring Boot does a very nice job in compressing the content of these requests. That sort of minimizes the actual bandwidth need over the network. And also, what really moves over the network is mainly just header data. The actual content is very small. Depending, you click on a button, we just tell that, okay, this button was clicked. Maybe some text field was changed somewhere. All right. You could, for example, consider using WebSockets. So out of the box, Vaadin supports just with using the push annotation ability to enable WebSocket-based communication with Vaadin, meaning that the header information is much smaller in size, and the content that is moved between the client and server is even smaller than what it would be with the traditional HTTP request response cycle. And as you, of course, Josh, already mentioned, the Spring session and all the different mechanisms on doing the deployment on the cloud environment will also further help deploying and using Vaadin applications that are highly scalable.
Right, and you can use Spring Session outside of a cloud as well. So if you want to plug into something that knows how to scale horizontally, like a Memcache or Redis or whatever, and you're not running in cloud, that works just as well, right? You can get scalable sessions that way. Another question we got in the last round was about security, and we didn't touch on that too much here because that's one of the places where work is being done. But if you check out the Vaadin for Spring integration, you can see that there is work being done to support security, and indeed there's even a sample there. So go ahead and check that out. There's also support for TouchKit and the MVP pattern, as well as the Navigator pattern. So lots of good stuff here. I encourage everybody to take a look and follow along at home. Yeah. Lots of good stuff as well, and we'd love to see feedback.
Yeah, actually, there was a question regarding mobile support, and now that you mentioned TouchKit, every Vaadin application is, of course, a web application that you build so that you use them with your web browser. So any mobile device that is able to display web browser, take any iPad or smartphone or anything like that, depending on your application layout, all the things, how you have built the look and feel of your application, they work out of the box with any mobile device. And for example, the Vaadin theme engine, the Valo 7.3, enables you to create a responsive layout, meaning that the content inside your Vaadin application will change according to the actual screen size of your viewing device. So you can, for example, use the same Vaadin UI all the way on the desktop, and when you put that to, let's say, your smartphone or iPad, you can, for example, completely change the order of the components, the look and feel it's sort of like a CSS media query kind of thing, but with the difference that it also works starting already from IE8, which is quite impressive today.
Yeah, and I would mention that this stuff is pretty layout friendly. No matter, even the regular desktop stuff is just really, really flexible and fluid. So you get really nice experience there. By the way, for the one other question people asked last time, and the reason I think we forgot to cover it, the reason why we're looking at /UI instead of just /root, by default you get /UI. But what we wanted to demonstrate was that this is an application that coexists with Spring MVC. So if you have Spring MVC in the back end and you want to have a REST endpoint or whatever, there's no reason it has to be an either-or discussion. In fact, there's a property that we provide called Vaadin.servlet.url mapping, and that maps the Vaadin app to /UI /*. So if this property is not there, then you'll just get everything at / will be the Vaadin app. But the benefit of doing this is now I can go to some of these other endpoints that Spring Boot contributes that are convenient for getting insight and so on. For example, paste the list here. Trace gives you a log of every request made into the application, for example. So this is invaluable for understanding what's happening and when it happened and the headers that were sent back and forth. env gives you a list of all your properties in the environment, etc. Lots of good stuff there. So, health, for example. Health gives you a nice endpoint that tells you about the health of the application. If you have a database, it'll know about that. If you have, whatever, it'll know about that. So this is a Spring MVC app with Vaadin. It's not either or. You can use one for, one use case and the other one for the other.
Yeah.
And I would imagine building any sort of back office or departmental or intranet-y kind of apps are perfect for Vaadin, and indeed a lot of
It's actually more like a question of selecting right tools for the right problem, meaning that Vaadin is great for any kind of business application, any kind of administrative application, anything you can imagine. But then again, I wouldn't build a website with Vaadin, since Vaadin is not about building web pages, it's about building applications, and that's completely different.
Exactly. Couldn't say it better. So, good stuff.
Actually, one more thing, if I may. I sent you a little link into the chat window, if you can find that from the WebEx. Probably can, probably not. Anyway, let's try it this way. Open that dashboard, So this is a Vaadin quick ticket dashboard. You can just click sign in. You don't have to put any information there. This is just a dashboard application to display, for example, movie sales information that might be interesting for staff of a movie theater, for example. And this application is very much responsive. So if you change your browser window size, for example, scale it a bit bigger, or let's say a bit smaller would be better, since it's already in full size, I think. Just grab the right edge and put it smaller. So with this way, you already now see that the menu has shifted to the top left corner. And if you do that, then it becomes a little bit available. And this is, for example, the tablet size. So the left-hand menu is responsive. And when it's in the mobile phone size, then the menu icon appears on the left top corner. So all these kind of things you can build with Vaadin right out of the box.
Wow, beautiful. Cool. Well, thank you, Peter. This was a lot of fun as usual. I enjoy when we get to hang out. I hope everybody else enjoyed it too. I guess with that we'll close it out. Thank you very much to everybody for coming. Thank you guys at Vaadin for all the fun. And this webinar will be online, so don't worry about that. Code is down there. Check out speakerdeck.com/Josh Long, and the slides will be there as well. And with that, I'll hand it back to Amy. Oh, Amy.
All right. Thank you, everybody. Also on behalf of us.